This video covers section 11.2 and 11.3. It is solving systems of linear equations using matrices. This is a pretty hefty topic, so if you need to pause the video, if you need to comment and ask a question, please do. This topic is new for a lot of people. A lot of people haven't seen matrices, and so be patient with me as I explain, and then be patient with yourself too as you try to figure it out. All right, so systems of equations in relation to an augmented matrix. So an augmented matrix helps us solve equations. And so, for example, over here I have this system of equations. And if I wanted to write as an augmented matrix, I would have this big bracket. And then each row of my matrix, I'll use colors here so we can see it, will correspond with a row in my system or equation in my system. Okay, so we're going to take this first column will be the X column, and then we're going to have a Y column, a Z column, and then an equals column, and that equals column is going to have a line before it's separating it. So I'm going to erase that, but just so you can kind of see what's going on. Okay, so for this first equation, I have a 3 for my X value. I have a 2Y. I have no Z, so I do need to put a placeholder of 0, and then I have a 5. For my middle equation, I have a 1 for X, a -1 for Y, a 3 for Z, and then equals 1. For my bottom equation, I have 2X plus 1Y plus 1Z is equal to 4. And then I'm going to close my matrix. And then it's augmented, and what that means is we have this line separating the left side from the right side, and that's just in place of the equal sign. So let me erase these highlights, but if you need to put those into your notes, go for it. Okay. This next part says write the augmented matrix associated with the given system of equations. So here they give us 7x is equal to 9 plus 2y, and 2 times x minus y is equal to 4. Neither one of these are of the form like that one was, of standard form, and so we need to switch the form on these before we can write the matrix. Okay, so I'm going to do the first one first. So I have 7x is equal to 9 plus 2y. I need to get my y on the other side, so I'm going to subtract it. And I have 7x minus 2y is equal to 9. So that's in standard form, so I'm good on that one. Then I'm going to look at my second equation. 2 times x minus y is equal to 4. I'm going to distribute this 2, and I get 2x minus 2y is equal to 4. And now I have two equations in standard form, so I can write this as an augmented matrix. So from the first equation, I have 7, -2, 9. And for my second equation, I have 2, -2, 4. All right, for this next one, it says write a system of linear equations that represent the given augmented matrix. So we're going backwards of the previous problem. And here, this first column is x, this second column is y, the last column is the equal sign. Okay, so when I have that, for the first one, I have 1x is equal to -8. And for the second one, I have 1y is equal to 3. So there's really not much to that one because of these zeros here. Kind of cancels out the other variables. All right, so we need to talk about row operations. So instead of just explaining it, I decided to pull up some examples. So we're given this augmented matrix, and we're going to apply these operations to them. And then I'm going to apply them as 3 separate problems. I'm not going to take my answer here and go this way, if that makes sense. All right, so for this first box, it says that we want to take R1 and switch it with R3. So this would break the symbol right here. Means switch. Okay, so when I do that, I'm keeping row 1 the same, so I'm going to rewrite 4, 3, 0, 5. I'm keeping my first row the same, and then I'm switching R2 and R3. So my new R2 is going to be 2, 0, -3, -8. And then my new R3 is going to be 1, 4, -1, 9. Okay, for this middle problem, it says -1/2 of R3, and then it doesn't say what to do, but we're going to replace R3. So if it's just something that looks like this, you would just multiply that third row by -1/2. So I'm going to keep my first two rows the same. So I'm going to have 4, 3, 0, 5, 1, 4, -1, 9. And then I'm multiplying R3 by -1/2. So that would be -1, 0, 3 halves or 1.5, and 4. Okay, for this last one, we're going to do 4 times R2, add it to R1, and then replace R1. So that's kind of a lot there. We are replacing R1. So R2 and R3 are staying the same, so I'm going to rewrite them. 1, 2, 4, 0, -1, -3, 9, 8. So this right here means replace R1, and we're replacing it with this right here. So it says -4 R2 plus R1. So I'm going to kind of break that down here. So -4 times R2 would be -4 times, and this is not really mathy, but I just kind of to show my work. -4 times 1, 4, -1, 9. And then we're going to add that to row 1, which is 4, 3, 0, 5. I guess let me change that color here. So for this part, I'm going to use pink, just so we can kind of see what's going on here. So what this original problem wants us to do is multiply -4 times R2 and then add it to R1, and we're replacing that first row. Okay, so when I do this, again down here, I'll label it scratch work down here. When I do this, I'm going to have -4, -16, +4, and -36. And we're adding that to row 1, 4, 3, 0, 5. And when I do that, I get -4 plus 4 is 0. -16 plus 3 is -13. 4 plus 0 is 4. And then -36 plus 5 would be -31. So this is my new R1 because it says replace R1. So up here, I would have 0, -13, 4, -31. Pause there if you have any questions. Please let me know because the next few examples, I'm not going to show my work like that. This is kind of what I'm going to be doing in my head from here on out. So if that's confusing to you, slow that down and look at it again and let me know if you need some help. All right, so next thing we're going to be talking about is row echelon form and reduced row echelon form. So two different forms. A matrix is in row echelon form if it satisfies the following conditions. Number 1, any rows consisting entirely of zeros at the bottom. For all other rows, the first non-zero is 1. So it's either all zeros at the bottom or the first non-zero entry is 1. And then number 3, the leading 1 in each non-zero row to the right of the leading 1 is immediately above. And then note a matrix is in reduced row echelon form if it is in row echelon form with the added condition that each row with the leading coefficient has a 0 above the leading 1. Okay, so that's a lot here. Echelon form means that this left corner is all zeros, and this picture is not very good, but these would also be 1s here. 1, 1, and 1. Reduced row echelon form has that same thing, that left corner is all zeros, but this one, the right top corner is also zeros. Okay, if we are solving a system of linear equations using Gaussian elimination, we are going to write an augmented matrix for step 1. Step 2, we're going to be using elementary row operations to write the augmented matrix in row echelon form. Let me highlight that because it's a vocabulary word. So row echelon form, we need 1s in the diagonal and 0s in the bottom right corner. And then 2, use back substitution to solve the resulting system. Okay, so again, I'm going to go pretty fast with the operation. So if that is confusing to you, please ask a question. Slow down my last example where I did the row operations, but yeah, here we go. So you are going to need to write pretty tiny to fit all your work in here. So let me make my pen a little smaller too. So the first thing I need to do is write my system as an augmented matrix. So that would be 2, 7, 1, and then 14 on the other side of the bar. And then my middle equation would be 1, 3, negative 1, 2. My bottom equation would be 1, 7, 12, 45. Okay, the first thing that I want is a 1 in this top left corner, and we're going to kind of work our way down. So the first thing we want is a 1 in that top left corner, then we want a 1 in the middle spot, and then we're going to want a 1 in the bottom spot. Okay, so that's kind of our three goals. So notice here, I have ones, oops, sorry. I have ones already in these two slots. So if I switched these two rows, I'm going to have my first goal. I'm going to have a 1 in the top left spot. So from this matrix to my next matrix, I'm going to switch row 1 and row 2 so I can get a 1 in that top left corner. Okay, so my new row 1 is going to be 1, 3, negative 1, 2. And my new row 2 is going to be 2, 7, 1, 14. And then I'm not changing my third row. 1, 7, 12, 45. Okay, so I have my desired 1 here. So I'm going to highlight that in pink so I kind of remember that. That's good. Now I need a 1 here and here, but before I do that, I also need zeros here, here, and here. Okay, so I'm going to start by trying to get a 0 where that 2 is. So from this step to the next step, if I do row 2 minus 2 row 1 and then replace row 2, that's me utilizing that top 1 and getting a 0 where my green highlight of 2 is. Okay, so I would be primarily using my calculator, but if I do, I'm going to keep my top row. Let's go ahead and rewrite it. And I'm keeping my third row for now. Okay, but to get my middle row now, I'm going to do row 2. So I'm going to show my work and then erase it. Really tiny. So row 2 minus 2 times row 1. So I'm getting that from this pink and green here. Okay, so for this middle one, it'd be row 2 minus 2 times row 1. And I'm showing my work here, but I would use my calculator for all of this, okay? So this one would be row 2 minus 2 times row 1. And then here, row 2 minus 2 times row 1. Okay, so that whole green highlight, I'm applying this elementary rule, replacing row 2, all in my calculator. Okay, I'm going to go back and instead of leaving that ugly matrix, I'm going to go ahead and write what that would be. So 2 minus 2 times 1 is just going to be 0. I don't think my eraser can get smaller. Oh, yes, it can. Okay. So here, 2 times that would be 0. 7 times 2 minus 3 would be 1. 1 times 2, or 1 minus 2 times negative 1 is going to be, I'm sorry, 1 would be positive 3. 14 minus 2 times 2 will be 10. Okay, so my first goal was to get a 1 here. My second goal was to get a 1 here. And naturally that ended up happening even though we were just really trying to get a 0 right here, okay? So I highlighted those in pink to know that, okay, I'm kind of good on those 2 rows. Now I'm trying to get a 1 where that 12 is, but I also need zeros where the 1 and 7 are. So before trying to get a 1 where that 12 is, I'm going to try to get rid of this 1 right here. Okay, and so in order to do that, I can utilize my row 1, and I can subtract my row 3 and replace row 3. Okay, so I'm going to rewrite my row 1 and 2. So 1, 3, negative 1, 2, 0, 1, 3, 10. And if I do row 1 minus row 3, that's going to be 1 minus 1, 3 minus 7, negative 1 minus 12, 2 minus 45. Okay, so I'm not going to leave it like that, but just you can kind of see what we're doing here. So if I actually do the math on that one, that 1 minus 1 is 0. 3 minus 7 is negative 4. Negative 1 minus 12 would be negative 13. 2 minus 45 would be negative 43. Okay, so again, I'm trying to get zeros here while getting ones here. Okay, so I'm starting out okay with my ones, and now I have 2 zeros, and I need a third zero where that negative 4 is. Okay, so I'm going to highlight that negative 4. I'm trying to make that a 0. And so to go to my next matrix, which I think I'm going to have to jump to the top of the page, I'm going to utilize these two numbers to try to get that negative 4 to be a 0. So what I'm going to do is I'm going to do row 2 plus, I'm going to do 4 times row 2 plus row 3, and that will give me a 0 where that green negative 4 is. Okay, so I'm going to write the matrix here, but I'm going to end up dragging it up to the top. So here is my new matrix. I'm going to have my top 2 rows are not going to change on this step. But the bottom row, I guess, will be right here, and then we're going to replace row 3. Okay, so for my bottom row, I'm doing 4 times row 2 plus row 3. 4 times row 2 plus row 3. I'm trying to write really small, sorry. 4 times row 2 plus row 3. 4 times row 2 plus row 3. So again, I'm not going to leave it that messy, but what you can see, I'm applying this right here and replacing my third row there. Okay, so 4 times 0 plus 0 is 0. 4 times 1 plus negative 4 is 0, which is what our goal was. 4 times 3 plus negative 13 would be negative 1. 4 times 10 plus negative 43 would be negative 3. I'm going to double check because I'm not wanting to make a mistake here. Yes. So this right here is going to be negative 3. Great. Okay, just for space, I'm going to, I know you can't do this on your paper, but I'm going to drag this up here just so I have some more space. Okay, so now we have this. Remember, our goal is to have zeros in the bottom left corner and ones in the diagonal. So we're very close to our goal. All we need to do, I'm going to highlight these in pink because they're good. I don't think I did that over here. Oh, I did. Let me erase this green over here. Okay, all I need to do is make this negative 1 into a positive 1. Okay, so to my next matrix, which is going to be my last, I'm going to do negative 1 times row 3 and then replace row 3. So I'm going to keep my top 2 the same, 1, 3, negative 1, 2, 0, 1, 3, 10. And then if I multiply everything by negative 1, that would be negative 1 times 0, negative 1 times 0, negative 1 times negative 1, negative 1 times negative 3. Okay, negative 1 times 0 is 0, negative 1 times 0 is 0, negative 1 times negative 1 is positive 1, and negative 1 times negative 3 is 3. So now I have zeros in my left corner, I have ones in my diagonal, so this is called row echelon form. Okay, it did want us to solve this using the row echelon form, so I need to rewrite this as a system. So the new system that it gives me would be 1x plus 3y minus c is equal to 2 from the top row, and then y plus 3z is equal to 10 from the middle row, and then 1z, or just z, is equal to 3 from the bottom row. And then it wants us to go backwards, so how did they word it? Back substitution to solve the rest of the system. So if I have z equals 3, I can plug that into this one to find y, and then I'll have y, and I'll plug this one in to find x, okay? So I have y plus 3 times 3 is equal to 10. Notice here I took my second equation and plugged in a 3. When I solve this, I have y plus 9 is equal to 10. If I subtract 9, I get y equals 1. And then I'm going to take z equals 3 and y equals 1 into the top equation. So I have 1 plus 3 times 1 minus 3 is equal to 2. X plus 3 minus 3 equals 2, or x equals 2. Okay, so this system turns into x equals 2, y equals 1, z equals 3. And a lot of times they're going to make you write it as a point. So for this one, the solution would be 2, 1, 3. I feel like I forgot. Oh no, good. All right, so the next one, oops. The next one is Gaussian-Jordan elimination. And so in Gaussian, I guess let me make a note here. For Gaussian elimination, you want row echelon form. And then for Gaussian-Jordan, we'll do the two examples, but here you want reduced row echelon form. So it's a little more work. So for this problem, I was able to stop at row echelon form and then solve the equations. Here it wants you to actually go all of the way. Okay, so the first thing we need to do is to set up an augmented matrix for this system. So I'm going to have 1, -2, -1, and 4, -7, 1. So for Gaussian-Jordan, we need 1s in our diagonal and then 2 zeros in the corners. Okay, so luckily I have a 1 here where I want it, so I'm going to highlight that in pink. The next thing I want to try to do is get a 0 where the 4 is. So from this matrix to the next matrix, I'm going to do 4R1 minus R3 and then replace R3. Okay, so what that's going to look like, I'm going to keep my top row. And so I'm going to write tiny, but 4R1 minus R3. I don't know why I put 3. I meant 2. So 4 times -2 minus -7. 4 times -1 minus 1. Okay, so 4 times 1 minus 4 is 0, which is what we wanted. 4 times -2 minus -7 would be +1. 4 times -1 minus 1 would be -5. I feel like I did something wrong. Hold on. Okay, this should be a -1 here. Okay, great. So we have this 1 where we want it. We have this 0 where we want it. And now I want to make, I'll use yellow, I guess. I want to make that -1 into a +1. Okay, so for my next step, I'm going to do -1 times R2 and then replace R2 with that. I'm going to keep my top row, 1, -2, -1. And then on the bottom row, I'm going to be doing -1 times 0, -1 times -1, and -1 times -5. Again, I'm just showing my work. I'd be doing all of this in the calculator. So -1 times 0 is 0. -1 times -1 is +1. -1 times -5 would be +5. So now we have two things in the two ones where we want them, and we have a 0 where we want them. Now we need this -2 to be a 0 as well. Okay, so the next thing I'm going to do is I'm going to use these two numbers to try to get that top -2 to be a 0. So I'm going to do 2 times row 2 and add it to row 1 and then replace row 1. Okay, so I'm keeping row 2 this time, so I'm keeping 0, 1, and 5. I'm going to do 2 times row 2 plus row 1, 2 times row 2 plus row 1, 2 times row 2 plus row 1. Again, I'm doing this all by hand, but I would do this in a calculator for sure. All right, 2 times 0 plus 1 is 1. 2 times 1 plus -2 is 0, which is what we wanted. 2 times 10 plus -1 would be 9. And here, since we have 1s in the diagonal, and zeros in the corner. This is called reduced row echelon form. Okay, so we get this system, x equals 9, y equals 5. And there's no substituting, it's already done for us. So for this one, the solution is 9, 5. Okay, and if we really wanted to check that, we could plug in 9 and 5 into our original system. Okay, so yeah, with Gaussian-Jordan or reduced row echelon form, there is no substituting back in. Because of these zeros, it's already done for us. I'm going to take off these highlights just because it's kind of hard to see. All right, this last one is the same thing, but it's 3 variables, so it's a lot more tedious. So pause as you need to. Again, I'm going to go pretty quick because I'm going to put a lot of this in my calculator, but again, pause as you need to. Okay, so the augmented matrix for this one would be 2, 7, 11, 11, 1, 2, 8, 14. And then my last row would be 1, 3, 6, 8. So really quick, again, we're trying to get ones in the diagonal and then zeros in the corners. Okay, so this is a lot of work, but then there's no substitution. So kind of like the one we did before, if I switched row 1 and row 2, I would get a 1 in the top left corner like I wanted. So that's what I'm going to do first. I'm going to switch R1 and R2. So my new row 1 is going to be 1, 2, 8, 14. My new row 2 is going to be 2, 7, 11, 11. And then I'm keeping row 3, 1, 3, 6, 8. Okay, the next thing I want to do is try to get a 0 in this spot right here. So from this matrix to my next matrix, I'm going to be doing row 2 minus 2 row 1, and then I'm going to replace row 2. Okay, so I'm going to do most of this in my calculator, so I'm keeping row 1, and I'm keeping row 3 for this step. And for the middle, I'm doing row 2 minus 2 row 1. So really tiny, that would be row 2 minus, oops, row 2 minus 2 row 1, row 2 minus 2 row 1, row 2 minus 2 row 1, row 2 minus 2 row 1. Double checking that real quick. Okay, yeah. So for this, 2 times 2 minus 1, this would be a 0. 7 times 2 minus 2 would be a 3. 11 times, or minus 2 times 8 would be a negative 5. And then 11 minus 2 times 14 would be a negative 17. Okay, so we have this 1 where we want it, and now we have this 0 where we want it to. Okay, great. The next thing I'm going to try to do is to get a 0 where this 1 is. And because I have 1 in row 1 and row 3, I'm going to subtract them. So from here to the next matrix, I'm going to do row 1 minus row 3, and then I'm going to replace row 3. Okay, so my new matrix would be, well, first off, I'm going to keep my first 2 rows the same. 1, 2, 8, 14. 0, 3, negative 5, negative 17. And then I'm doing row 1 minus row 3. So 1 minus 1, 2 minus 3, 8 minus 6, 14 minus 8. Again, I'm showing my work, but I'd probably do this in my calculator in real life. 1 minus 1 is 0. 2 minus 3 is negative 1. 8 minus 6 is 2. 14 minus 8 is 6. Okay, the next thing I want to try to do is to get a 0 where this negative 1 is. And I'm going to utilize row 2 to do that. And the reason why I wouldn't use row 1 is because row 2 has this 0 here, so that kind of helps keep things the same. Okay, so from this step to the next step, I'm going to do row 2 plus 3 times row 3, and then I'm going to replace row 3. So what that's going to look like, I'm keeping my first 2 rows the same again. And then I'm going to do row 2 plus 3 row 3. So 0 plus, let me zoom in so I can make it small. 0 plus 3 times 0, negative 1, oh, sorry, not negative 1. 3 plus 3 times negative 1, negative 5 plus 3 times 2, negative 17 plus 3 times 6. 0 plus 3 times 0 is 0. 3 plus 3 times negative 1 is 0. Negative 5 plus 3 times 2 is 1. And then negative 17 plus 3 times 6 is 1. Okay, so we got lucky here because we were just trying to get a 0 here, but we ended up getting a 1 here as well, which is great. Okay, so the next thing we probably want to do is get a 1. Well, actually, no, let's try to get this negative 5 to be a 0, and we'll utilize row 3 to cancel these out. So I'm going to keep my row 1 the same, and I'm going to keep my row 3 the same. And so from here to here, to cancel out that negative 5, I'm going to do 5 times row 3 plus row 2, and then I'm going to replace row 2. Okay, so again, really tiny. 5 times 0 plus 0, 5 times 0 plus 3, 5 times 1 plus negative 5, 5 times 1 plus negative 17. 5 times 0 plus 0 is 0. 5 times 0 plus 3 is 3. 5 times 1 plus negative 5 is 0, which is what we wanted. 5 times 1 plus negative 17 is negative 12. All right, let's see, what did I do next? Yeah, so the next thing I want to do is to try to make this 3 into a 1. And so from this matrix to the next matrix, I'm going to do 1/3 times row 2 and then replace row 2. So basically I'm just multiplying row 2 by 1/3. So I'm going to keep 1, 2, 8, 14. And my bottom row 0, 0, 1, 1. And then that middle row, 0 divided by 3 is 0, 3 divided by 3 is 1, 0 divided by 3 is 0, and then negative 12 divided by 3 turns into negative 4. Okay, so now I have this matrix, and I am, just so we remember, I'm trying to get 1s in the diagonal, which I have. I have 0s in my bottom left corner. Now I need to try to get 0s in my top right corner. Okay, so I'm going to focus on making this 8 into a 0. And so from this matrix to the next matrix, I'm going to use row 3. And I'm going to do row 1 minus 8 row 3. And then I'm going to replace row 1. Okay, so when I do that, I'm going to rewrite my row 2 and rewrite my row 3 because I'm only changing row 1. And I'm going to change row 1 really tiny. I'm doing row 1 minus 8 row 3, row 1 minus 8 row 3, row 1 minus 8 row 3, row 1 minus 8 row 3. So again, I'm doing that in my calculator. 1 minus 8 times 0 is 1. 2 minus 8 times 0 is 2. 8 minus 8 times 1 is 0, which is what we were going for. 14 minus 8 times 1 is 6. Okay, So again, we are trying to get ones in our diagonal and then zeros in both corners. So the last thing we have to look at is this 2 right here. And I'm going to utilize row 2 to cancel out that 2. So this will be my last step really, but from this matrix to my last matrix, I'm going to do row 1 minus 2 row 2 and then replace row 1. Okay, so when I do that, I am rewriting row 2 and row 3. And then my row 1 is going to be row 1 minus 2 row 2, row 1 minus 2 row 2, row 1, oops, row 1 minus 2 row 2, row 1 minus 2 row 2. Okay, when I actually multiply that out, 1 minus 2 times 0 is 1. 2 minus 2 times 1 is 0, which was our goal. 0 minus 2 times 0 is 0. 6 minus 2 times negative 4 is 14. Okay, so I have ones in the angle. I have zeros in both corners. So this is reduced row echelon form. So using Gaussian-Jordan elimination, we get reduced row echelon form. Our system becomes x equals 14 with the top row, y equals negative 4 with the middle row, z equals 1 with the bottom row, and then if we wanted to write it as, I guess a point, we would write 14, negative 4, 1. And then to check our answer, we could plug that into our original system.